Good morning, students. Welcome to next video lecture on problems related to organic chemistry, that is related to enantiomer, diastereomer, and identical, etc. In my previous video, I discussed what you mean by an enantiomer, how can you draw the structures of enantiomers, diastereomers, etc. In this video, I wish to discuss some compounds will be provided. We have to identify that two compounds is enantiomer or diastereomer or identical. Okay. Before let us discuss. Before we are moving to the problem. Let us take what do you mean by an enantiomer and what do you mean by diastereomer. Okay. First of all, let us remind what you mean by enantiomer. If the main condition enantiomer means these are mirror images. What is that? These having mirror images, and all the configurations get changed. So if a compound having configuration R, S, R, if it is changed to S, R, S, R is changed to S, S is changed to R, R is changed to S, we can call it as enantiomer. If a compound having R configuration, if it is changed to S, R is changed to S, R is changed to S, both the configurations are be changed. So such kind of enantiomer or compounds are known as enantiomer. Let us talking about the diastereomer. These are not mirror images, but the configurations may be changed. So I told in the previous video that it is only applicable to a compound which contain more than one chiral center. Minimum 2 chiral centers are exist. Okay. So if we are not changing the position of at least one, if we are not moving, or if we are not changing the positions of groups of any one of the chiral carbon atom, and the other one's positions or the groups get interchanged, then we can say that that is an example for diastereomer. If we are standing or by discussing, or we are discussing this problem by in basis of configuration, if the configuration is changed to, if the configuration of one compound is RRR, if it is changed to RRS or RSR or SSR, any change, if it is SSS, which means only one possibility for enantiomer, other all possibilities for this R and S configurations combinations, we can call it as diastereomer. That is the thing that we are going to discuss in the given problems. Okay, let us, without spending much time, I am moving for the problematic session. This is the problem. This is the question that I taken from the model question paper. Find of whether the following molecule are enantiomer, diastereomer, or identical. This is compound, I name this compound as A and this is compound as B. We have to find that if it is mirror images, that is if it is enantiomer or if it is diastereomer, or if both are identical. The best and the easy way for identify or to crack this problem is that let us find the configuration of these compounds. So from our previous classes, or by in our knowledge, the easy way that it is difficult to find the configuration of compound in Sohouse. So the easy way that we have to convert it into Fisher. In Fisher, we can easily identify whether the compound is, we can find the configuration easily. So by taking first example, first of all, we will solve the first compound, then we will move for the second one. So this is the first compound. You can see that I call it as, this is the back carbon and this is the front carbon. Okay. So we have to convert it into what the state, that is to the Fisher representation. How can you convert Hall's to Fisher? There is a condition for the conversion. What's the condition? Here we can see that this is for an easy understanding, this is a Stargate conformer. How can you identify the Stargate? Here it is Y, here it is A. If it is A, you can see that here 2, here 1. So we can see that if you look at from here, we can see it's there is no masking element. So it is a Stargate 1. It is a Stargate 1. What do you want to do that? First of all, convert it into eclipsed form. How can you convert? Just by fixing the back carbon, just rotate clockwise. I am rotating clockwise. If you are rotating back, that is anti-clockwise, no problem. I am rotating the this. Then we get the current. We get the eclipsed form. So the back carbon does not have any change. I mark it as this is H and this is OH, and the bottom positions is created by COOH. Then the other one having the same configuration, it's like this. We are rotating just like so. On the bottom position it will be placed by H, then it is OH, then it is CH3. Finished. This is front carbon and this is back carbon. Front carbon is always represented here. This is front carbon, which is the bottom H, so H can be placed here. On left, OH, so OH can be placed here. Here it is CH3, so CH3 can be placed here. If let us talking about this back carbon, COOH is pointed towards the axis, so we can put it is on top. COOH, left side is decorated by H, or it is situated by H, and the right position is decorated by, or it is satisfied by OH group. So the conversion is over. What about the next point? We have to give the priorities and we have to find the configuration. Here if we are looking that this is O, here it is attached to C, here it is attached to C, here it is attached to H. So first priority is given for 1, that is for OH. Second priority, we know that if H is there, then it should be having 4th. Then the only confusion is that which is 2, which is 3. Here the carbon which is attached to carbon, so carbon priority get cancelled. In one side it is C, other side it is C, other side, and one satisfied by this will be satisfied by H. In this case, all the 3 valencies were satisfied by H. So we can say that the priority is more on the above side. So this is 2, and this is 3. Note it, 1 to 2 to 3. Is it clockwise or anti-clockwise? This is the clock movement, and H is on bottom, or the lowest priority is on bottom or top. We can say that this is R. Got it? Here let us move for the numbering of this. This is 1, this is we can say that here COOH group is there, so 2, this is having 3, and this is 4. So let us draw 1, 2 to 3. This is anti-clockwise, but it is on the horizontal, so we can say that anti-clockwise is R. So the configuration of this compound is, if you are numbering from here, because COOH is the most priority, 1, 2, this is the second carbon, and this is carbon, third carbon, so we can say that that is 2R, 3R. Okay, let us find the configuration of the other one. This is let us similarly we can convert it into the eclipsed form. So let us draw the picture, or it is in the eclipsed form. So yeah, that is so simple. Yeah, so the first position COOH, the second that is OH and H. If you are rotating, this is the CH3, then top is by OH and this is by H. Just convert it into this. Front carbon rotated by CH3 and left by OH, right by H. Top by H, left by COOH, right by OH. Right? Is it? Yeah. I forgot that. I think that there is a mistake that is happened. Okay, no problem. Here let us give the numbers. So first priority has to be given for OH. The fourth is for this, and this is second, and this is third. So we can say that 1 to 2, sorry, 1 to 2 to 3. Is it clockwise? Yeah, but we can say that H is on horizontal, so this is S. Here this is 4, this is 1, this is 2, this is 3. 1 to 2, right? 1 to 2, 1, sorry, that is not 1 to 2 to 3. Yeah, then only the rotation will be complete. This is anti-clockwise. So we can say that it is on the top. So lowest priority is on the top. So anti-clockwise is yes. So we can call it as again we can say that this is 2 yes and 3 yes. In the previous case, then first compound is 2R 3R. It is changed to 2S 3S, isn't it? Here it is 1 to 2 to 3. This is clockwise. Lower priority is on right horizontal. So it is yes. Here 1, 2, 3. So this is anti-clockwise, but lower priority is on vertical. So that is yes. So 2R is converted to 2R, 3R is converted to R is changed to S, R is changed to S. It is enantiomer. All the configuration is changed. I think that you got